Stop wasting time with bogus airflow readings. Use the heat capacity method with the heating, ventilation, and air conditioning temperature rise formula to calculate cubic feet per minute accurately by placing temperature sensors exactly where they belong in the ductwork. To measure airflow with the temperature rise method, you are using the formula CFM equals total heat output divided by 1.08 times temperature rise, where 1.08 is the product of air density and specific heat at sea level for standard indoor conditions. That makes precise temperature rise essential. Drill quarter-inch holes for bead-type sensors, one in the return duct just before the air handler, and one in the supply trunk at least 12 to 18 inches downstream of the heat exchanger or coil, and out of the line of sight of any electric strip heater to avoid radiant bias. Use fast response thermistors or Type T thermocouples with accuracy of plus or minus 0.2 degrees Fahrenheit and insert them so the bead is centered in the airstream, not touching metal. Seal probe holes with removable grommets or foil tape after insertion to prevent pressure and temperature leakage that skew readings. Stabilize the system for 5 to 10 minutes at steady heat output before logging. Collect at least 60 seconds of 1 second interval data and average to reduce turbulence noise. Verify zero stratification by rotating the sensor across the duct cross-section. If you see more than 2 degrees Fahrenheit spread, add mixing distance or use a multi-point average. Correct for electric heat staging by confirming which strips are energized and using the actual kilowatts from clamp meters and voltage readings to compute total heat output. Then confirm nameplate versus measured kilowatts match within 5%. If gas heat is used, compute total heat output from manifold pressure, measured gas flow, and measured flue losses or use manufacturer input and steady state efficiency because nameplate alone can mislead when supply pressure deviates. One of the most common HVAC airflow testing mistakes is placing the supply temperature sensor too close to the electric strip heater or heat exchanger, which causes radiant overheating and inflates temperature rise. Fix it by moving the probe 12 to 18 inches downstream, out of line of sight, or using a 90-degree elbow as a radiant shield to get a true mixed air temperature. One of the top airflow measurement errors is installing the return temperature sensor in a room return grille instead of the return plenum, which adds room heat gain and underestimates true temperature rise. Correct this by mounting the sensor in the return duct within 12 inches of the air handler inlet, upstream of any filter bypass leakage, and confirm no outside air is mixing between sensors. One of the biggest airflow calculation issues is using assumed heat output and the 1.08 factor without correcting for actual air conditions, leading to incorrect cubic feet per minute. Solve this by measuring real-time kilowatts for electric heat or confirmed burner input for gas, adjusting the constant for altitude and moisture if needed, and validating with a second method such as external static pressure plus blower table. BigHomeProjects.com lists vetted heating, ventilation, and air conditioning contractors who understand airflow diagnostics, temperature rise testing, and sensor placement, so homeowners get accurate cubic feet per minute assessments and better comfort. Contractors use BigHomeProjects.com to showcase credentials, collect verified reviews, and win jobs from homeowners seeking trusted local experts for airflow measurement, duct repair, and system balancing.